And then as I have been doing lately, I'm running a dual stream. So there's also YouTube Live going at the same time for anybody over there that want to engage on that side. Okay, just a couple minutes. Okay. Morning, Lisa. Hey there. Okay, we'll get things rolling in just a bit here. Hey, Mike, Brian, Eileen, Jeannie, everybody here. Welcome back, Daphne. Good to see you too. Hi there, Ho and Michaela. Okay. So I guess now is a good time to start. No time like the present. So we're at pretty much 10 a.m. Welcome back, everybody, and thanks for attending today. I know we've had a little time away from class, at least from the Zoom meetings, because last week Thursday was Veterans Day, and Tuesday by design we had some videos to watch on media marketing and digital literacy. So that brings us back, and now we're going to start talking about a new chapter in the book. Let me just give you a clear outline for the next few meetings, how it's going to go. And this is all listed in the syllabus too, so none of these dates have changed, but basically today we start talking about chapter 12, which is science. And then Thursday we have a second lecture on the same chapter to finish off all the notes. Then next week on Tuesday, a week from today, that's when you'll have your third quiz, and it's just going to be on this chapter of science. So you want to do your best to pay attention, take good notes, read the chapter for sure, and then you should be in good shape to take the quiz next Tuesday. And then next Thursday is, of course, Thanksgiving holiday, so we won't have any meetings or class for that date, obviously. And I modified the due date for the third assignment. So hopefully some of you guys have noticed that I sent around the instructions for homework assignment number 3. Let me know if anybody can confirm that you've seen those details in the Canvas. Okay, good. Thanks, John and everybody, Eileen. So let me say just a few things about that assignment. So the third homework assignment, which I always use, is to try and get you guys to find examples of fallacies in the media, in marketing materials, in commercials, in advertisements of whatever kind. You're going to just try to find different clear examples of some of the fallacies that we've learned about, as many as possible, hopefully all 20. And if you do find all 20, and you could just give me a file that contains either images or links to all of them, whether they're just still images, printed magazine ads or whatever. That's usually, I think, a good source to look at. If you have magazines like fashion magazines or full page color ads, they usually have a lot of these fallacies in them. So that's one thing that I've used in the past. When we had physical meetings, I would have the students all come in and bring a magazine and then work in groups to find the fallacies. But since this is a online class, you'll have to work individually and find them on your own. But you have plenty of time. So the due date that I extended is anytime before midnight on Sunday, the 28th. So that's after the Thanksgiving holiday. It's just the weekend of the Thanksgiving week. So you've got, I guess that means still about 12 days to do it if you haven't started yet. And yeah, so you want to try and find fallacies. Now, I sent some videos, like in one case, there's a video that was at the end of the links that I shared. which just shows examples of fallacies in like different Axe body odor, like deodorant commercials. And then there was some discussion of them also in some of the videos by the guy Jay Smooth, who does that Crash Course Learning series on media literacy. So just to give you like some examples, you could look at that. Of course, online, you're going to find all kinds of different examples too. But I wanted you to be able to try and find the examples without just necessarily using a crutch of like a Google search that says, here's fallacies with this example or with this, with this type of ad. So there's 20 fallacies. If you get all 20, you're going to get full credit. And yeah, you can turn it in anytime, but no rush. It's due Sunday the 28th. So if you need further details on it, you can always go back to the original class announcement that I sent. But just kind of wanted to keep you aware of that since we hadn't been able to talk about it in the live meeting yet. So anyway, Sunday the 28th, before the end of the day, just make sure to email me your submission for the third homework. And what we're looking at now is, we're getting closer to the end of the semester. We have that quiz next Tuesday on science on chapter 12. And then you have your third homework that comes into me before the 28th. And then when we return from the holiday break, we just have one more chapter, which is chapter 9, and that's about ethics and morality. And so we'll just have a few lectures on it. And then you'll have one more, not one more quiz. This is going to be the last quiz next Tuesday, but you have a final exam and then a fourth homework assignment. So once we finish this quiz and the third homework, I'll give you instructions on the fourth homework, and then we'll just start getting ready for the final. But okay, everybody. So just wanted to kind of clear the air on those things. Nothing too amazing or shocking. It's all part of the class and it's part of our syllabus, but I just wanted to, keep you in touch with it. So if you haven't done it yet, feel free to go ahead and just leave a comment if you want, for attendance purposes. I think probably most of you have, but if you didn't get a chance, make sure to leave some type of comment in these chats, whichever one you'd like. And okay, so I guess now we're good to go. And as usual, if you have questions, comments, or any other kind of input for the meeting, then just go ahead and leave a typed comment or use your microphone if you wish. And I'll hear you or see your comment, and we'll just talk about it, whatever. Okay, then. So let's go ahead and continue. Right now, we are going to start talking about chapter 12, which is all about science. Okay. So in the beginning of many of the chapters of the book, they kind of give some real world information to draw your interest onto the topic of the chapter. In the beginning of chapter 1, there was some information about these social psychology experiments, Milgram and Zimbardo, to show you the value of being a good critical thinker and what the risks are if you're not. In chapter 3 on language, there was some little reference to the Benghazi scandal with the attack on the U.S. embassy in Benghazi, Libya, in 2012. That shows why good communication is important and why bad miscommunication can lead to harm. In chapter 4 about knowledge, we talked about some famous medical mistakes, cases of medical error, like somebody amputating the wrong leg, which reminds us that we can all make cognitive mistakes and errors in the processing of information when we try to have knowledge. So we got to be careful. And we've talked a little bit about media and marketing in the lectures that I sent to you before. And we talked about fallacies. We talked about the case of Shannon Townsend at the beginning of chapter 5, who got caught up in the cult movement because she was not able to determine when bad arguments, fallacious arguments were being given to her by these cult leaders. So now it's chapter 12. And the beginning of chapter 12 mentions the case of global warming to kind of bring your interest level out in the topic of the chapter. So science. One of the things that we know from our scientific research and the scientific community's consensus is that global warming is an increasing problem. Basically what happens is we have a lot of carbon emissions, and that's hi Jeannie, you asking if I'm recording the meeting. Yeah, I'm recording it on YouTube, and that's what I've been using lately to share the meetings because there's a better, I think, image. But just to be fully comprehensive, I don't have any problem also recording the Zoom meeting for anyone that might want it. So I'm going to go ahead and get it started then. Thank you for that. Okay, so now There we go. Now it's recording just in case someone would prefer the Zoom playback, and I can send it to those that want it if they want it on a case-by-case basis. Anyone can email me for that. Okay, thank you though. And good morning to you too, Omar. Okay, so yeah, global warming. There's carbon emissions and fuel emissions, which result in trapped carbon in the Earth's atmosphere. And because of that, it creates a greenhouse effect, which causes the planet to warm up over time gradually. So these trapped carbon emissions and so forth in the Earth's atmosphere are causing global temperatures to rise. And that's resulting in all kinds of negative and destructive side effects for the planet and for human beings. For example, it's causing sea levels to increase because melting Arctic sea ice is one consequence of global temperatures steadily increasing. And so, because these sea levels are rising, it's causing all kinds of erosion in coastal areas, and it also threatens the future of coastal cities and regions because, according to some estimates, if we are not able to get these problems under control and mitigate the rise of global temperatures due to climate change, then we could have as much as a foot or more of increased sea level rise before the end of this century. And that's not good because people like us living in California, we're close to the coasts, so we're staring down a possible century here where if we can't control the global warming problem, some of these coastal regions could actually be submerged in water or heavily degraded. So the problem has really gotten worse, actually, since probably the turn of the 21st century, the past 20 years, and especially the past 10 years. In fact, the statistics are kind of a little intimidating because let me give you some facts. Yeah, so the hottest 5 years that have ever been recorded since we started recording temperature in 1850 have all occurred since the year 2010. So yeah, we've had the hottest years ever recorded, all clustered towards the tail end of the timeline of history, meaning that it's increasing and it seems to be kind of accumulating towards the current day. In the past few decades, the warming trends have accelerated. Temperatures are expected to increase by another 2 to 6.5 degrees by 2100. There's this big international climate summit going on, or that just was going on in Copenhagen, the COP26 climate treaty or summit rather, and they're trying to limit global temperatures to less than 2 degrees. But some experts say that without more direct and kind of radical reforms, we'll probably won't be able to hit that target, and maybe we'll be something closer to 2.5, which can still lead to a lot of erosion and melting of sea ice. And that says in the book, with massive droughts, deadly heat waves, and massive storms, January 2019 was the hottest January recorded in the United States. The melting of the polar ice sheets in response to increased warming of Earth is in part responsible for rising sea levels. In 2002, a part of the Antarctic ice shelf the size of Rhode Island broke off and fell into the ocean. And rising sea levels also contribute to land erosion as well as to the salinization of fresh water and agricultural land in low-lying areas, thus disrupting the food and water supply. It's also causing more aggressive storms to happen during hurricane season because of the thermal currents in the air that are generated by the different heat and temperature conditions. So anyway, this reminds us as critical thinkers that we have to be able to interpret and evaluate scientific information that we hear, whether that's in media, in scientific journals, or what we hear anecdotally from other people relayed to us. So in this chapter, we will try to get a clear view of science, what it is, what its history is, what some of its basic assumptions are. We'll talk about the steps of the scientific method. We'll also distinguish what are qualities of a good scientific hypothesis or theory. And we'll talk about the difference between real quality science and pseudoscience, which is like false or fake science. Okay, so I guess the best place to start then, and hi, good to see you too, Monica and Hamad, Omar, everyone else that's arrived to the meeting. We'll start off with a clear definition of science that's given in the book. So science, what even is it? It is this: it's reasoning from observable facts to testable explanations for those facts. So So there we go. You see the definition in the chat. Science, reasoning from observable facts to testable explanations for the facts. So in science, we start with observation. We just observe the world, we notice things happening, we notice phenomena occurring. And then a scientist doesn't just want to stop there like, hey, a volcano erupted, nice. They want to observe this fact, but they want to eventually be able to explain why. What's the reason that the thing happened? And so the goal in the end is explanation. We want to be able to explain the cause of events that we see so that we know why they happen, and therefore we can control them in some cases or prevent them in other cases if we don't want those things to happen. So we want to be able to provide explanations for the facts that are testable. We want to be able to provide testable explanations. So the explanation for the phenomena should be something that a person could perform an experiment or test to verify that it's the correct explanation. So, like if you're seeing the volcano erupt, the next step is, why did that happen? And if I can generate an explanation of why, then I should be able to create a controlled test, which will be able to replicate these conditions and show you that the same cause-effect relationship could be repeated under those conditions. So in science, we want to understand things about the world. We don't want to just have things happen. We want to know why they happen so that we have some insight into it, and then we can have a little bit better control over the things that are happening. So we discover and observe and collect facts, and then try to explain their occurrence and also the relationship between them. Welcome back, Kylie. Good to see you. So science is the major source and method for gaining knowledge about the world around you. If there's any question that you have about how things work, what causes something to happen, then you'd go to science to find your answer. If you want to know why the sun comes up, why it gets cold at night, why volcanoes erupt, why lightning is striking, why plants grow, what is photosynthesis, what is the weather cycle, or biological processes of the body. How does vision work? How does hearing work? How has certain life forms adapted to their environment? All these questions, the best source and method to turn to get answers would be science. So we have to have a heavy dose of respect and I would say consideration for scientific research and results. All of us owe a heavy debt to science, because without it, we would not have all the modern conveniences that we all take for granted, right? Like the fact that we're even sitting here talking through this, computer interface using the internet. It requires extraordinary scientific progress to be able to develop these technologies. And so even though sometimes people don't like the things that science says because they may sound scary, or they may make you think that we're not as special as we thought we were, or whatever, it's really delivered to us all the trappings of modernism that make our lives so much better than our, recent ancestors who just had to basically farm and, live off of the land. So no disrespect to the farmers, obviously, but it's a different world now, right? With all of the modern technology and structure and infrastructure that we have. So science, it's the major source and method for gaining knowledge about the world. And when you use science, you're reasoning from observable facts to eventually getting testable explanations for those facts. Now, next thing the book talks about, which I want to talk to you about, are some important people in the history of Western science. So one of these people is Nicholas Copernicus. And first of all, I'll let you know when he lived. He lived from 1473 to 1543. And he discovered something very important. And many people credit him with kind of launching the scientific revolution. Some people even refer to his work as the Copernican Revolution. So what he did was, first of all, he's a Polish astronomer. Okay, so there's our little bit of information about Copernicus. So he lived from 1473 to 1543. He was a Polish astronomer, meaning he would, use telescopes that were just now being invented with greater powers of observation to examine the night sky and the motion of the celestial bodies that are out there in space. And he was able to discover what's known as the heliocentric model of the solar system, a very important discovery, which replaced the older geocentric model. Does anybody have a guess or even just knowledge about what the heliocentric model says? Let's see if anybody has a view on this or if you have anything. If you don't, that's okay too, because I'll certainly tell you if you don't, but that's correct, Michaela, yes. And same with to Eugenie, right. The heliocentric model is the modern model that we all know is true today, which says that all the planets in the local solar system, they revolve around the sun. Before this, so helio, it means sun, and centric means centered. So sun-centered model of the local solar system and the local cosmos. This replaced the older geocentric model. Does anybody have a guess or better about what the geocentric model means? The older view before the new heliocentric model. What was it? Right, that's correct. They used to think that the Earth was at the center of the solar system. And part of that was due to the work of a man named Ptolemy, who's like a second century Egyptian astronomer. But that view was considered very important to the early generations of the West because it was supposed to be consistent with theology. You see, they actually thought that God, right, would not have wanted to create the planet Earth with human beings that, according to the Bible, are created in His image, and the universe itself, according to those religious traditions, it's made by God for the sake of man. So, like, we are the children of God, created in His image. So they thought that He would want to have put us right in a central position to have a pride of place, as it were, so that everything revolves around us and that we are, the centerpiece of the universe. That was such an important idea to the church and to, the West, all the way up until the end of the medieval period. As we start getting into the Renaissance, this view was challenged by empirical observations that were done using these new telescopes. But they really didn't want to concede the point. In fact, Galileo, he's another important scientist and astronomer from the same period as Copernicus, and he also found the same results using telescopes, that the sun is the center and not the Earth. But can you believe this? It was considered such a heresy. It was considered such an unorthodox thing to say that they considered it to be sacrilegious. And the church at the time threatened Galileo with death. They said, we're going to execute you unless you go out in public and you get in front of everybody and you say, I don't know what I was talking about. I must have been possessed by the devil or something, because it's not true. The sun is not at the center, but instead it's the Earth. So Galileo had to, publicly recant his testimony under penalty or fear of death. And he was 70 years old at the time, an old man that is half blind by looking at the sun too much through telescopes. But he did have to do that. Now, in the centuries that have passed since then, the church has actually formally apologized to Galileo and his descendants, because there's no debating it anymore. I mean, we have sophisticated satellites, and we have like Hubble telescopes and things that clearly map out the picture of the local cosmos. And so there's no controversy at all. It's definitely the sun that's at the center, and the 8 or 9 planets revolve around that central point. But this is considered a revolutionary discovery in the history of science, because it opened the door to gaining a little distance between scientific research and what the church wanted. And it started to show that through scientific investigation, we could discover facts about reality that in some cases deviate from the orthodox teachings of the church. That had been suppressed largely all the way through the medieval period. Some people call them the Dark Ages or the Middle Ages, when the church was the dominant institution. So if you received, let's say, like an education, it would not have been in the current day system where there's a separation of church and state. Your lessons would have been infused with theological lessons and church stories, or biblical stories. So this was an important key discovery, everybody, the discovery that the sun is at the center of the solar system. As much as it seems like an obvious point now, we know we're the third planet from the sun and all the rest. This was a radical idea at the time, or it was perceived to be such, just because it went against and defied the orthodox views of the church. There there were kind of some views or reasons why some people did think that the Earth was at the center. They believe that it seems like you're standing still when you're on the Earth. It doesn't seem to be moving. That if it was moving, some people thought if you jumped up, then the rotating or moving Earth underneath you should slide underneath you. But that's all incorrect because you share the same state of motion as the Earth itself. So you're moving along with it. Just like if you're in a car and you flip a quarter, it's not like the quarter is going to fly to the back of the car as the car rushes underneath it because it's moving with the same velocity as the frame of reference that it is a part of. So that's called Galilean relativity. And that's one of the reasons why we know that despite the perception one has from an observer on the surface of the Earth, it's definitely moving and it's rotating around the sun. One thing that Copernicus and Galileo were able to also discover using these telescopes was that the planet Jupiter has its own moons. And that meant that the planet Earth is not unique in having a moon. So it's just another planet like other planets are, which has like these little local orbiting satellites. That gave further credence to the idea that we are in an orbital path around the sun. Also, in Ptolemy's older view of geocentrism, to make that idea consistent with what was observed through telescopes, they had to assume that the planetary motions went in what are called epicycles, which are like curlicue corkscrew patterns. And that's obviously not true either, according to what we've been able to observe, and also the work of Johann Kepler. We know that planets and other objects orbit around each other in smooth elliptical orbits and not weird curlicues. So anyway, that's some information about an important figure of early Western science, Copernicus, who discovered the heliocentric model. Now, another important figure from the early Western history of science is Sir Francis Bacon. So I'll tell you about him. Sir Francis Bacon, he lived from 1561 till 1626. And what he discovered, or I don't know if I should say discovered, maybe more created, is the steps of the scientific method. So okay, so just typing out a little info on Bacon. Sir Francis Bacon, mentioned in the book. I'll read a few things on these points from the book. So Sir Francis Bacon created the scientific method and is sometimes known as the father of modern science. In his book of 1620 called Novum Organum, he put forth a method based on direct observation for discovering truths about the world. And of course, we still use the scientific method every day, all the time, in the practice of science and sometimes in just everyday life. And welcome to class, Michael. I see you there, so no big deal. Good to see you. Talking about Bacon, yes, he did formulate the steps of the scientific method in his famous book of 1620. And yeah, I got that in both chats. Oh, and not to worry, I see you there. Another student just DM'd me that just arrived, so just sending back a quick message to them. Okay. Right. So yes, the scientific method, there's a series of steps in it. We're going to talk about them in much more full detail in the next class lecture. So I've saved the scientific method notes for Thursday. But basically, you start off by observing something that you want to explain. Then you try to generate a hypothesis to at least give a reasonable, educated guess as to why it happened. And then from there, once you've got your hypothesis narrowed down, you try to conduct an experiment that can test whether the hypothesis is true or not. And based on the results of the test, you either are going to confirm the hypothesis or it will show that it was wrong. If it's confirmed, you would publish those results and forward them to the scientific community so they can replicate them on their own. Or if the hypothesis was not confirmed by the test, then you would have to go back to the drawing board and come up with a different one. But anyway, we owe a lot of gratitude, again, I would say, to science, because the scientific method is what generates all the forms of technology that we use. And so if you like living in a world where you have easy access to communication, transportation, medicines, and all the rest, then science is what you should say thank you to. Okay, so we've talked about Sir Francis Bacon and Nicholas Copernicus. The next thing we'll talk about are what are some assumptions behind science. So these are just some fundamental assumptions that are baked into the work of scientists and to the scientific community. Um, so these are things that science has to assume for it to even do its work. And we want to know what these baseline assumptions are. So we're going to go over a few. To start off, one fundamental assumption of science is something we've actually already encountered earlier in the semester when we talked about knowledge, and that is empiricism. Maybe somebody has even a memory or knowledge of what is empiricism. Empiricism, it's a view about where most of our knowledge comes from. That's a hint. Maybe you can remember the rest. Someone let me know if you have it. Empiricism, most human knowledge comes from where? Because we have talked about it once before, so I'm just checking to see if that's something. I hope it hasn't been lost on you yet. You say our primary senses? Yeah, that's right. So the five senses and observation, correct. So this is the belief that most human knowledge comes from the five senses and observation. Okay. That's one of the big assumptions of science, empiricism. Science assumes that by using our five senses and the tools that we can use to enhance our ordinary powers of perception, like telescopes, microscopes, or stethoscopes, whatever, um, that would deliver us knowledge about reality. Since science is all based on observation, you observe the world and collect data about it, and then you try to explain the events that you have observed. It prioritizes the observational method of gaining knowledge. So science does rely, on math and logic as well, which are more rationalistic. But it's essentially based on inductive reasoning, starting with things that have been observed and trying to generate explanations for them or predictions about what's likely to happen under certain conditions. So if we did not think we could gain knowledge from five senses and observation, then science wouldn't work because it's all derived from um, observation of things. Okay, so that's one major assumption of science, something that we've touched base on earlier. Another fundamental assumption of science is the concept of objectivity. So I'm going to write that in here and talk about it too. So objectivity is the belief that we can learn about the universe as it really is, not just as it appears to be, and that we can do so without any bias. So okay. So I just put a little emphasis or accent on the term really because um, that's a base idea within the concept of objectivity, that there's a real outside world, that it has a definite objective nature, not a subjective nature, and that we can come to discover and learn these objective facts about reality. So objectivity, it's often contrasted with, like, the objective is often contrasted against the subjective. Objectivity is sometimes contrasted with subjectivity. So even though I know you're learning this from me and we're studying it now for the first time, I bet you've had some experience with the use of these words, at least in some ways, before. So let me test your intuitions here with a couple of simple questions. If I tell you that vanilla is the best ice cream flavor, is that an objective statement or a subjective statement? To say that vanilla is the best ice cream flavor, is it objective or subjective? Correct, Eileen. That's subjective, right? And why would you say so? You're giving the right answer, but can you give me your reason behind it? Why do you say it's subjective? It's just my personal preference. That's right. It's just an opinion, and therefore it's not something that we can say is like an objective fact. If other people have different preferences on ice cream, I can't say they're like wrong because that's just about their taste and about their own view. But if I say that the Earth is the third planet from the sun, is that objective or subjective? That is objective, yes, because it's not just my opinion, and it doesn't matter if I disagree. That's just an objective fact, whether I like it or not. It's true, objectively, that the sun and the Earth have that spatial relationship. We're the third planet out. It's, I think, you've got Mercury, Venus, and then Earth, then Mars, and then on to the rest. So, in science, we believe that we're not just talking about our feelings and our perspectives on things, but that we are getting to the objective truth about reality, that there's truth to be discovered and that we can really get there without bias. So science does not think that we are just sort of out here giving our opinions on things or stating views where there could be a diversity of different views. In science, we try to get to the objective truth, and the belief of science is at least that that's possible, that there is objective truth, that by using the tools of reason that we have been given, that we can come to discover these truths. And I really do think that there's a lot of evidence in favor of this idea because if we did not discover objective truth with science, and if we were just, let's say, coming up with theories that, sound good to some people, but they're just subjective opinions, then we would never be able to develop all the technology that we have. I know I've said this a few times, but it's an obvious fact. How could a microwave possibly work if we were just playing a guessing game of opinions about how the fundamental forces of the electromagnetic spectrum work? We have to be getting to the accurate, correct answers for our technology to proceed as it does. And so the efficiency and actual function of many things that we've created technologically do show that we have knowledge about the way that the reality is constructed. We've built atomic bombs, for example, based on principles of atomic physics. And if these principles were not correct, then the bombs wouldn't work, and so on, even with the computer that you're using. So, yeah, another assumption of science is that we can discover the facts about reality as it really happens to be, not just as it seems to be, and that we can get there without bias. Okay. Now, another assumption of science, a third to add to our little list here, is what's called materialism. And materialism, now there's another meaning of the word. We've talked about equivocation earlier in this class, when you have a single word that can have different meanings. And this is the case with materialism. So I want you to make sure not to confuse it with a different meaning. It's like a social meaning that doesn't have anything to do with its scientific usage. Sometimes you call a person a materialistic person if they just care about their clothes or their appearance or the way they look, or their possessions. But that's not what we mean by this term in the scientific context. So materialism is not like an obsession with money or possessions. Materialism is rather something much more academic. It's this. It is the belief that everything in the universe is made out of physical matter. And importantly, including us and our consciousness. Okay. So, materialism, it's the belief that everything in the whole universe is made out of physical matter, even us and our consciousness, our, thoughts, feelings, memories, hopes, dreams, fears, emotions, all of those things are just based on matter, physical matter. Now, what is matter? Physical matter, in the most basic description, well, what would you call it? What is the most small unit of matter that often we use a word to refer to? When you break things down, they get to atoms, right? An atom, in the classical sense, is a Greek word which means not cuttable, uncuttable, so it can't be further divided. So little fundamental particles of matter, atoms, on the materialist view, that's everything in the universe. Everything around you is just different groupings of atoms bundled together to form larger scale objects, including even you and me and our consciousness. So according to materialism, there's no such thing as a soul. There's no such thing as an afterlife or a ghost or a spirit, because what consciousness is, according to the materialist, is the physical brain operating according to its neurological and biochemical processes. So there's no possibility, therefore, for there to be like a disembodied consciousness that floats free with no physical body to support it. So if you've heard of, ashes to ashes and dust to dust, the physicalist would say, the materialist, another word for it is physicalist, but the materialist would say that without the brain working, there's no possibility for consciousness because there's nothing that can support the existence of consciousness without a physical brain that works or functions. So according to materialism, there's no such thing as ghosts, spirits, souls, or anything else. There's just matter operating and interacting with other parts of matter according to the physical laws of nature. So I don't know. Some people find that a little depressing. They might think, well, okay, that's sad because I thought it was something that was, like a spiritual being, not just made out of atoms. But I don't know. I mean, it's still pretty rich and interesting, the concept of having consciousness, that consciousness could somehow be developed out of an initial condition where you just have a bunch of inanimate matter. At the beginning of the universe's history, according to physicalism, there's no life yet, there's no consciousness yet. It takes billions and billions of years for chance processes to eventually lead to the existence of life forms like us. But according to materialism, it's all made out of matter, and there's nothing in the universe that's not made out of matter. All things are material, and there's nothing that's not. So consciousness and thought is just another physical process playing out. It's brain waves, it's conscious states and neurological states, but it's not anything other than that. So I know that's called materialism. Some people also refer to it by another name, and I mentioned it in passing just now, physicalism. Honestly, I kind of prefer the other name of physicalism because it avoids false associations with like the unrelated definition of materialism. But the book anyway goes with the label materialism, so I'll just use that for the sake of in keeping with the book's design. But when I teach it in other classes, it's described as physicalism, but same idea. Okay, so you guys understand that? Everything made out of matter. It's an assumption of science. Science assumes that we live in a physical universe that's governed by physical laws of nature, and that covers everything, including the existence of consciousness and all the rest. Here's what it says in the book about it. Materialism. Scientific materialists argue that everything in the universe is physical matter. Materialism in this sense has nothing to do with being obsessed with acquiring money, consumer goods, and other material things. According to scientific materialism, perceptions, thoughts, and emotions can all be reduced to descriptions of physical systems, such as brain waves or stimuli and response. There's no need to bring into scientific descriptions and explanations extraneous, non-material concepts. Because of its materialistic roots, science has made little progress explaining how matter can become conscious. So, an assumption of science, but it is still a mystery how consciousness comes to exist on the physicalist hypothesis. But evidently, we do have consciousness because here we are as we, consciously observe this lecture. So it certainly exists, and what's the basis of it? According to materialists, physicalists, it's just made out of matter. Very complicated physical object, the brain, but a physical object nonetheless. Okay. And I'm not saying these are true assumptions either. I'm just listing out for you information provided in the book, not trying to, disclaim anybody's assumptions to the contrary. But in talking about science, you do have to understand what it assumes and what it believes, and that's true about science anyway. Next up, another assumption of science is called predictability. Okay, so with predictability, the assumption is this, that the universe is orderly and predictable. So that means that established cause and effect relationships would be repeatable and would hold forever. So I'll write that and then we'll talk about it. Okay, so we can see that definition there, predictability. This is another key assumption of science, and the assumption is that the universe overall is orderly and predictable. So established cause and effect relations will be repeatable and they would hold forever. Now, let me try and show you an example of what's being claimed here. Okay, I don't know. let's say that I have this marker right here, which I do have. And I'm going to tell you right now, I'm about to release my grasp. I'm going to just, open my hand while I'm still holding it. I haven't done it yet, so I'm asking you to give a prediction. What do you predict would happen if I just let this thing go? That's an easy question, I guess. But let me know what you think. That it would fall. Okay, Michaela. Now, how do you know? Why do you think so? Okay, Alex, you say gravity. Good. But the law of gravity says so. Okay, good, same. Kylie, if I was in space, it would float. We haven't disproved that you're not in space. Well, I guess, yeah, you could argue this, possibly. Nothing to hold it up, John. That's good. But I want to get even a little more deep with it, okay? So you guys are giving good answers. That's all good. That it will fall, and it will fall because of gravity, and because the law of gravity will make it fall. But question, what makes you think the law of gravity is going to work right now, today? I mean, it used to do that, but how do you know that the law of gravity is not going to just stop operating today? Why do you think it will still keep working? I mean, I know it's always worked in the past, but what about, today's November 16th? Maybe today's the last day that gravity is going to work. So how do you know it will still keep working? Because it has never not worked in the past. There you go, Michaela, good. It's like induction, isn't it? You can't guarantee to 100% certainty that the future will resemble the past because we haven't been in the future yet, right? But judging based on the record of past history, it seems that there's never been one exception. And therefore, we assume, don't we? We assume that these laws of gravity and other physical laws will last for how long? Not just for today or just for tomorrow or for some limited temporary time period, but we assume that it will always hold. So let's see. Your prediction was correct. And the reason is simply because of the assumption that we've provided here. The assumption that the universe is orderly and predictable. So basically, the laws of physics and nature will be permanent and that they will operate in the same way under the same physical conditions, not just here and now, but at all times and places where the same conditions are repeated. Now, have we had the whole future to see me drop this infinite number of times? No. But the assumption of predictability is that if we had an infinite amount of time, wouldn't that be great? And if I just kept doing this for all time, that it would just keep falling forever and that it would never do something different like float away or turn into a chicken and just walk off or something. Because we assume that the universe is not unpredictable like that it's predictable so that once we have figured out how things work scientifically, that those principles hold for all time because we think the universe operates according to stable and set rules, you know? And yeah, Kylie, that would not be great if you started to float off the planet before your 19th birthday. And I'm sure it won't happen. But I guess I have to rely on an assumption that it won't happen. Now, why is this an assumption? Because it's an assumption of something that can't be absolutely proven. Can you prove that tomorrow the law of gravity will not cease to exist? I guess you can't prove it, but you do assume that it's never going to change. And so scientific community assumes the same, that the laws of nature are stable, permanent, and that they're not just somehow temporary or for a limited time only. Okay, so like whether that's gravity or other things, inertia, entropy, laws of thermodynamics, all these things should continue to operate in the same exact way if the same conditions are replicated. And it does say this so in the book. So on predictability, the book says, scientists have traditionally assumed that the world is orderly and predictable. The universe consists of interconnected causal relationships that can be discovered through systematic observation and inductive reasoning. So there you go. Another main assumption of science, predictability. So just one more of these assumptions of science, and then we'll talk about some limitations that science has, as well as, if we can get into it today, different views about the relation of science and religion. But one more of the core assumptions of science is what's called unity. And this is the assumption that there's an underlying unity to the universe, such that eventually everything could be explained according to a single set of scientific laws. So then unity. This is the assumption that the universe is unified, that there's an underlying unity to it. And what that means is that eventually we believe we can explain all things according to a single set of scientific laws and principles. That is the sort of holy grail of science. The goal, the objective is to eventually get to this. Sometimes it's called grand unified theory. I've seen the abbreviation given GUT to stand for a grand unified theory. And the grand unified theory is when we eventually hope to get to this state of having one set of laws and principles that explains everything from the biggest phenomena to down to the smallest little microscopic phenomena in the universe. Right now, we haven't quite got there because we have two different fields of explanation for the big and for the small. For the largest scale of reality, we have the theory of relativity, the special and general theory of relativity from Einstein. And then to describe the behavior of the tiniest things, the tiny little quantum particles at the nano level, we have quantum physics. And quantum physics and the theory of relativity actually don't agree at the margins, so they're inconsistent with each other. The belief of scientific community is that eventually we will get to a point where we will have some kind of bridge building theories that will integrate the relativistic and quantum descriptions of reality, but we don't have it yet. So it's a goal for future science. That's like the 21st century mission, to try and eventually get a set of scientific laws or principles that can describe and explain everything. But it's an assumption that we can get there because scientists believe since there's only one universe and it should operate according to one set of laws. Why should there be disjoint laws, one for big things and one for small? That's not parsimonious or elegant, I guess you could say. And so science assumes another thing, that there is a unified set of laws that we can eventually get to describe all things in the universe. Okay, now the next part of the chapter 12 talks about what are some limitations of science. It's kind of like, I don't know, I feel like these are also assumptions of science, but they describe them as limits because they're things assumed that cannot be absolutely proven. And you might see that as like something that science is limited by. It can't possibly answer these questions, so it just has to assume the answers. But one of them is this. Science assumes, so here I'll give the heading to the section of notes we're talking about, limitations of science. Now, some of these so-called limitations of science are a bit philosophical, so they might require a little more discussion and explanation than simply like a little definition. But I'll try to write something just to give you something to have in your notes. So one of the limitations could be that science assumes that the external world exists, but that cannot be absolutely proven. So okay, so I don't know if you remember, but we talked earlier in the semester about a man named Descartes, René Descartes, who's a French philosopher of the 1600s. And he talked about a method of doubt. The method of doubt says to assume to be false anything that you could possibly doubt. And with the method of doubt, he said, how do you really know that you're even having real experiences right now? Because maybe you're in a simulation and the world around you is just a dream or an illusion. Well, science assumes anyway that that's not the case. Science assumes that there is an external world around you, and it's not just all in your head, or that it's not just all like a brain in a vat being stimulated to have these perceptions by like a mad scientist in another dimension or something, or you're in the matrix. The scientist assumes that the external world really does exist and that you're in it and you're observing it with your five senses. But of course, this is an assumption that can't be absolutely proven, because suppose you were in a simulation right now. If you were, and it was a very good realistic simulation, then it would look just like this. It would look just like the actual situation of reality. So you couldn't possibly tell the difference between a simulation of reality and the real thing if you've never been outside the simulation. So science has to presume that there's an external world that we're studying and learning about and finding facts about. Otherwise, what would be the point, right? I mean, suppose you had Mario in the Mario Brothers universe, trying to like perform scientific experiments on those magic mushrooms to see how they work, what would be the point? Because the world he's in is not even real. It's a fake video game world. So there would not be any real information derived from that. So we assume in science anyway that you're not a character in a big simulation learning about a fake reality, but that you're actually learning about the real reality. Can this be absolutely proven? I guess not. But most of us don't have much problem assuming that that's true. So anyway, hopefully that makes sense to you, that science assumes what most of us take to be a given, that the external world exists. But nonetheless, we can say that's a limit because this is an assumption that can't be completely proven. Another assumption, or I should say limit rather, of science is that science can only study that which is observable. So we can call this another limitation of science. It can only study the things that are either directly or indirectly observable. But if there's something that can't be observed at all, and there's no way to observe it, then scientists would never be able to understand it or to formulate any kind of scientific theories about it. So that's a limitation, perhaps. If there are, for example, supernatural phenomena in the universe, if there are ghosts, souls, extrasensory perception, if any of these kinds of things exist, then they cannot possibly be the subject of scientific understanding because they're outside the realm of the observable and they can't be observed under controlled conditions. So science either assumes that they don't exist or that if they do, they're outside the scope of what a scientist can research. Even in science itself, not talking necessarily only about the supernatural or whatever, there are some things that can't be studied because they can't be observed directly or indirectly. Like the universe is expanding, and the expansion rate of the universe seems to be accelerating, which is very odd because nobody really fully understands what's driving this outward expansion of matter. If it had just been the Big Bang, projecting all matter outwards from a dense central point at the beginning, then something would eventually, the forces of gravity, cause it to contract. But that's not happening. It's all expanding further and further away from everything else. So some scientists speculate or hypothesize that it could be dark matter, which is driving this rapid outward expansion and in the inflation of the universe. But dark matter is called dark because it can't be observed in any way. So that's something that's also going to be hard for scientific community to fully grasp or comprehend if it exists. Okay, so a second limitation of science. It can only study the things that are observable. So if anything was not observable, for whatever given example, it couldn't be studied or understood by science. And I'll just say this one. Some people also find the predictability assumption to be a kind of limitation because, as I was sort of mentioning just a moment ago, in science we assume that the natural laws will never change and that gravity and other things like that will always work, not just today, but on into the permanent future. But we haven't been into the future yet, so we can't absolutely verify that these assumptions of predictability will always hold. Nonetheless, they've always held so far, so there's pretty good inductive reason to think that they won't change. But with induction, as you guys know, there's no absolute guarantee that the inductive conclusion will be true because it's not a deductive argument. So that could be seen as another possible limit of science. Okay, now, so the last thing I guess I want to speak to you about today before we break for our Thursday lecture is in the textbook. It next talks about different views about the relationship of science and religion. And it says there are 4 possible viewpoints that a person can have when it comes to the comparison and the contrast between science and religion. So here I'm going to list those and talk to you about them. 4 views about the relationship of science and religion. Now, much has been said about science and religion being in a somewhat of a conflict because, many have said that if you have a very strictly scientific view of the world, then that eliminates the room or space for a religious perspective on the world, and vice versa. Some will say that if you have a very, fundamental, devout religious perspective, then that's going to make it impossible to agree with certain scientific claims or theories. Now, some people believe that religion and science are more compatible than that they don't really have strong conflicts, but these different views will spell out what the different possible attitudes can be. So number one view would be the view that science takes priority over religion when the two conflict. Okay. So that's one view. Sorry here. Let me just list the four views first, I guess, this time, and then we'll talk about them one by one. The second view, which is like the reverse of the first one, is that religion takes priority over science when the two conflict. Okay, that's the second possible view or perspective. The third one is that science and religion are actually not in conflict. So they talk about different topics. Therefore, there's no conflict. So the third view, science and religion deal with different topics. Okay, science and religion deal with different topics, so they don't conflict. That's another view some hold. And finally, the fourth is that science and religion are compatible. So they're actually saying the same thing, maybe if you just interpret one or the other a certain way. So science and religion are compatible. Okay, so let's talk then about these four views. To start with the first. So to a person who says science takes priority over religion if they conflict, um, that means that if religion and science don't agree on something, like say, is evolution true or did God create us in his image? Um, is the sun at the center of the local cosmos or is it the earth because God would have wanted us to be in the middle? Does prayer have any ability to change things or does it have no effect whatsoever? Science and religion will take different views on any of these topics. And another possibility is, did human beings come to exist within the first 7 days of the universe, as it says in the book of Genesis, that God created everything and on the seventh day he rested? Or instead, did it take billions and billions of years for the planets to accrete from the original just scattered mass that we had at the beginning of the universe, and it took billions of years for life forms and then mammals and then humans to emerge? You know, these all seem to be conflicts between religion and science. And so if you hold the first view, then when these conflicts occur, if they do, you would break in favor of the scientific answer. So if science says that, you know, the universe is billions of years old, but there's a religious community that says it's thousands of years old, then if you hold the first view, you would take the scientist's claim to be accurate and reject the religious one. That you would go with evolution instead of creationism, or that you would say uh, that the planet Earth is not young but very old, or that the universe is very old in comparison to man, that contradicts the book of Genesis, stuff like that. So if there was a person that holds this first view, that's going to be a scientific realist. It's going to be the kind of person that rejects religion when it doesn't agree with science. Now, the second view is the opposite. So it's easy to say what that is. That would be a person who takes the other side when these conflicts appear to happen. So if they saw in a religious text that God created the universe in 7 days, but the science textbook says no, it's billions of years, then the person who holds the second view would say religion is correct and science is wrong. This would be the option for somebody who's, I guess, a devout religious practitioner, somebody who wants to not allow scientific challenges to their religious views. And the third view would be that no, they're somehow talking about different things. So they don't really have any conflict, or if they appear to have it, it's just a false appearance of conflict. So what could be these different topics? Some people think that science deals with the physical reality and with cause and effect, but religion deals with the spiritual reality and with morality and stuff like that, and values. So maybe if we think they're cordoned off into their own separate lanes, as it were, then there's no actual overstepping of their bounds and interfering with each other's work. But at the same time, I know a lot of people want to hold that type of view because it seems to be like inoffensive, like everyone gets what they want, scientists are correct, so is religion. But if you look at the things that science and religion talk about, though, they do seem to talk about the same things, at least in some cases, like the origin of man, the origin of the universe, um, the effectiveness of prayer, um, and things like that. So anyway, though, it's possible, and some will try to say that their religious views have nothing to do with their scientific views, and they keep them in separate domains. And the fourth view is that science and religion are actually compatible. So somebody will hold this view if they perhaps want to modify a fundamentalist interpretation of a religious claim so that it comes into alignment with the scientist's work. So for an example of that, let's see. We talked about how in the Bible it says that God created everything in 7 days, but according to science, it took billions of years just for planets to form, and then billions more for human beings to emerge on the surface of planet Earth. So how could a person maybe finesse the religious scriptural doctrine so that it's not disagreeing with the scientist? You might just say that, well, let's not take it literally. When it says 7 days, that might mean, can anybody give me a sort of response here? For a person who's trying to, square the differences between these. Okay, there you go, Michaela. What if God exists outside of our idea of time? So the Bible didn't mean it literally when it said he created these things in 7 days. Maybe all that happened was that's a metaphor for whatever unit of time God actually used, or something like that. A day is just an arbitrary conventional term, but it could mean a billion years, could mean a million years, or whatever. So that might not be a conflict. Or creationism versus evolution. In traditional religion, it says God created us in his image, so we didn't evolve from apes and from other mammals to get to this point. But that's what science definitely does say, and that's the consensus view of the scientific community. So I don't know, somebody might say, well, when it says creation, God just created the conditions, and evolution was the process that he wanted to use to establish beings in his image over a long span of time. So there's no conflict between creationism and evolution. Somebody could say that. The only thing I'd say about the fourth view is that it could be criticized for being ad hoc, which means that the person is just kind of trying to, after the fact, come up with an explanation that makes sense so that the two things don't disagree. But notice that these after the fact explanations never come before the scientist comes forward with a new theory. So it's not like anybody had any indication that they should maybe change the literal interpretation of how many days God took to make the universe until the scientific community starts to discover facts that contradict that traditional assumption. I often use this metaphor to describe the concept that I'm now mentioning to you. Suppose that somebody just randomly fires an arrow at the side of a barn. No aim, no intent to hit any particular place. They just fire that arrow and it hits somewhere. And then they go up to wherever it landed, and then they draw a bullseye around it. Now, is that person an expert marksman? No. That doesn't mean that they shot, perfectly on the bullseye. They just created the bullseye wherever the arrow happened to land. And so I sometimes think of it this way. The scientific community will come up with new theories, and then the religious community, in order to not seem, let's say, opposed to science, will sometimes relax the literal interpretations of their messages so that it doesn't seem to be so much different from what the scientific community has presented. But these decisions about modifying the doctrine or the interpretation of it only happen after the fact. And so it's hard to see that that's what was the intended message from the beginning, but that's just one view. So you guys have now learned about these different views concerning the relationship of science and religion. Most scientists and a lot of academic people are more in the first view. More traditional religious adherents are more in the second. Those holding number 4 may be willing to relax or reinterpret literal assumptions about biblical stories. And that's kind of the lay of the land on these theoretical possibilities. Now, there's more to say on chapter 12, but I don't want to rush through it too fast because I want us to have ample time in both meetings and not to be done too early. So I'll probably stop for now, and we'll resume on Thursday. When we come back on Thursday, we'll talk about the steps of the scientific method, and we'll talk about what are qualities of a good scientific hypothesis, and we'll also then talk a little bit about pseudoscience, which is like false or fake science. Um, but that's about all I guess I had to say for the moment. Is everything good on your end? Do you have any questions or anything that you want to say or let me know while we're here together? Just throwing it out there. Okay, thanks, Angelica. I appreciate that. Well, all right then, guys. So I think we've had a nice meeting. Remember, next Tuesday is going to be a quiz on this chapter of science. So you should take good notes. Make sure to watch the videos and prepare well. But we have one more lecture on it before we take that quiz. So I'll see you back on Thursday. I'll close the streams now one by one. So to everybody here on Zoom, thanks again, and I'll see you soon. And be in touch by email if there's anything you need. So, okay, bye-bye for now. Okay, cool. And thank you, Lisa, and everybody here on YouTube. It's been nice to have another good meeting with you guys. So I'm going to close the stream, but until next time, see you soon. Okay, bye-bye.